Hello everyone, welcome to my channel. This is Nageshwara, Department of Civil Engineering from Nalla Narasimha Reddy Education Societies and Group of Institution. Guys, today we will discuss some of the information regarding transportation engineering of second unit. We know very well this is highway geometric design. We are discussing last few days some of the important topic also, and here one of the important topic is SSD, that is stopping side distance. From the stopping side distance, we will solve one problem. We know very well what is stopping side distance, what is the minimum, what is maximum distance we required. We know very well this all kind of the information. Already we are discussed in derivation and we have solved some of the formulas over there. So now we will solve one problem from the topic. Yeah, guys, this is the problem. Calculate the stopping side distance, that is SSD, on a highway at a descending gradient of 2% for a design speed of 80 km per hour. Assume other data as per IRC recommendations. And one tabular form is given here, that is design speed in kmph, safe stopping side distance for design in meters. So here design speed is given, that is 20, 25, 30, 40, 50, 60, 65, 80 and 100 in kilometer per hours. Here safe SSD for design. So the length is given here. For 20 kmph is 20 meter and 25 kmph is 25 and 30 kmph is 30 and 40 kmph is 45 and 50 kmph is 60, 60 kmph is 80 meters, 65 kmph it is 90 meters and 80 kmph is 120, then finally 100 kmph it is 180 meters. Hey guys, here when we are observing, when speed is increasing gradually, then automatically here safe stopping side distance also increased. So means when a vehicle traveling with the maximum speed of 80 or 100 kmph, at the time we need to require more length to stop the vehicle. If the speed is maximum, then our stopping side distance is less. At that time we cannot control our vehicle, it may skid. So that's why we need to require maximum length, depends upon speed. So depends upon speed, we need to require the length according to the IRC recommendation. So guys, this is the problem we will solve. Yeah, this is the solution. So we know question is there. Yeah, here two components is there, two gradients is there here. One is the ascending order and second one is the descending order. So here the descending order is given in question, that is the negative here, that is the n percentage, means descending gradient is given, that is the negative, means is a minus 2% is the n value. N is nothing but descending gradient. And here some case ascending gradients also is there, that is the 2% of the positive. And here design speed is given, that is 80 kmph. So we need to calculate here stopping side distance of 80 kmph speed of descending gradients is 2%. So what is stopping side distance we need to calculate. And remaining values according to the IRC recommendation we need to assume. So here given data, here capital V value is 80 kmph is there, and here n value is minus 2%, and here G we know that is 9.81 very well, and we can calculate the remaining values according to that. And here another value V we can require in meter per second. So there is capital V upon 3.6. V is 80, and here value is 3.6. Then our value is 22.2 meter per second. So here two methods is there. So normal method is there, and as well as the when we are considering the speed 80 kmph, which is the alternate value also is there. We need to take these two information and we will calculate. So in first case, it is SSD. Generally SSD we know, log distance and braking distance we know very well. So in everywhere that is a common point. So here SSD in first case. So from the equation in SSD derivation, it is Vt plus V square upon 2G into F plus or minus N percentage. So why we are using here plus or minus, in the sense we have ascending order is there and as well as the descending order is there. So that's why we are using final formula. What we required or what he required from the question, then only we can use negative or positive. So then here descending order is given, so that's why we can take negative way. So Vt, V in the sense how much value here, 22.2. In this problem he given here 2.2, that is wrong, please observe that. So V is 22.2 meters and T value is here given, braking distance, that is a reaction time. Reaction time we know from the IRC recommendation, that is the 2.2 seconds, that is constant. Plus here V is 22.2 whole square. Then 2 into G is 9.8, we know very well, and F is equals to 0.35. So coefficient of friction also is constant for the 80 kmph value, and here the N percentage is the 0.02. That is a descending order now. So then here what is the value here? Complete value is 55.5. 55.5 is the log distance, as well as the 76.2 is the braking distance value. So finally our value is 131.7 meter. We can say here 132 meter. So according to the question, he asked what is the stopping side distance for the 80 kmph value. So guys, here for 80 kmph design speed of a given vehicle, it should maintain 132 meter of stopping side distance with descending gradient of 2%. That is the matter. Then there is an alternate information also is there with help of design speed. So here SSD stopping side distance is equals to 0.278 Vt. Here capital V in the sense that is the 80 kmph value, plus as well as here capital V square upon 254 into F plus or minus N value here also. So we are taking here N value. So I think here also some mistaken is there. 0.278 into V. Here V is the design speed, what he given in question, that is the 80 kmph value, and your T is common, that is the reaction time of the driver is 2.5, plus here V is 80 square upon 254 into F value is 0.35, that is the coefficient of the friction, and minus we are taking negative value, then N value is 0.2. So here the log distance is 55.6 plus braking distance is 76.4. So here complete value is 132. So guys, we are doing here two-way methods. So in first case we are getting here 132 meter length, and is the alternate method also we are getting 132 meters. So obviously when we are doing this kind of the problem, and we are using two methods, so that's why we are getting equal values. So final conclusion is here, when a vehicle moving with 80 kmph speed of in a descending gradient of 2%, so should maintain 132 meters of side distance to stopping. So with this speed, if we are maintaining 100 or something less, so then definitely it will be affected. So we need to maintain definitely more than 130, then only we are reaching in a safe information. Otherwise we cannot save the stopping side distance. So in some case also depends upon the design speed. If it is more than 80 or more than 100, then automatically what happened here, So the stopping side distance, it will be increased. Already we are shown, already he given in question. So when design speed is increases, then as well as same stopping side distance also increases. So it is design speed is less, the stopping side also less. So then only we can overcome all kind of the problem. So this is the information, guys. Thank you.